Hey guys, this is Akshay Sadavarte and I am your gyanibuddy for today. So today we are going to learn about what CRC error detection is and how it is implemented. Here is a list of some prerequisites which you should be familiar with, like what is error detection and correction and why it is needed, how does CRC work, the truth table of XOR and its working. I would recommend you to pause this video right here and check this all out through the link given in the description below. Now let's get down to actual business. So guys, I hope you have all gone through the prerequisites, but still to make things a bit more clear, we will consider an example here. Let's take the input to be equal to 1100, okay, and then we will consider our generator polynomial g of x to be equal to x cube plus x square plus 1, which can obviously written as x cube plus x square plus 0x plus 1, which will eventually give us coefficients 1, 1, 0 and 1. Okay, so now there is a procedure which we have to follow to find the checksum to ensure that the input is transferred properly. So the receiver will check this checksum, and the procedure to follow, that is that we don't know the checksum here, right? So we will add number of zeros equal to 1 less than the number of digits or bits in the coefficient. So here, as there are 1, 2, 3 and 4 elements, we will add 3 zeros here. Okay, that is number of elements minus 1, and we will divide it by our divisor, which are the coefficients. So let's do XOR now. So 1 would give me 1, 1, 0, 1. Doing XOR 1, 1, 0, 1, 1, 0, 0, 0, 0 and 0, 1, 1. Taking this 0 down. Okay, so now we can't divide it obviously, so we'll take 0. Getting 0 here would give me 1, 0. Taking this 0 down, still can't divide it, so again taking 0, going a bit down, 1, 0, 0 and taking this 0 here. Okay, so now it's 4 digit, first 1, 2, 3, 4, and this is also 4 digit. We'll see in the code why this is important. And finally we can do XOR again. So what we get is 0, 1, 0 and 1. So this is the checksum which is required. Okay, so we are going to replace it over these 3 zeros here. So what is the data which we are going to send is input plus checksum. So result would be 1, 1, 0, 0 and 1, 0, 1 instead of 3 zeros. Okay. So now on the receiver side, if the received data is, let's consider one case A, is equal to input plus checksum. So the receiver will verify the correctness of this data by dividing this received data with the same divisor. And as you know, this was the previous remainder which we were getting. If we XOR it now, okay, so it will give us remainder. Let's say we get something here, XYZ, we do something, and we will get remainder 0. So as this was the correct data which we sent and we got remainder 0, so the code will check if we get remainder 0, then only we can say that the data received was correct. Okay, else in case B, if the receiver gets any other kind of data, let's say 10111, okay, so when this will be divided, okay, it will definitely give a non-zero remainder. Okay, and this will tell our code that this is not correct and that some error exists. Now let's move on to the coding part. I hope you have understood this.
Hey guys, now let's start with coding. As you can see, I have defined the basic skeleton of our code. I have included all the necessary header files and have defined a class named CRC, right? In that, I have defined basic strings which we are going to need, as we have seen in the example earlier, the string name input, divisor, dividend, and result. Also, their respective lengths are of importance, so we will also define and int variables for the same. Also, we declare the specifier as public. Going towards main, in main, we instantiate our CRC class and name the object as small CRC. And these are some of the main functions which we are going to write in our code. So now let's write. So guys, now we write the void get data function here to input the data. Let me speed up this process a bit because it's a very basic and easy function. All we have to do is ask the user for input and then ask for the coefficients of the generator polynomial, and we take them respectively in the input variable and the divisor variable. Then we calculate their lengths using the length function, which gives us the length of our string. Similarly, we get the length of our input through input.length. Furthermore, we assign the input to our dividend variable because our input is our dividend, as you know. Then we declare an integer r which is equal to length of generator minus 1. So many of you must have guessed by now that we are doing this to add number of zeros equal to one less than the number of coefficients of divisor. So if our input is 1100 and we have to calculate the checksum, so we add number of zeros equal to one less than the number of digits in the coefficients. So we need to add 3 zeros here, right? If our divisor is also 4-bit, and this is achieved by this for loop right here. We iterate from I equal to 0 to I less than r, that is I less than 3. So we get exactly 3. So we exactly append or concatenate 3 zeros in our dividend, right? Furthermore, then we update the length of our dividend by dividend.length, and then we call the one of the important functions, modulo division function, which will eventually lead to us to do XOR. So we define it as void modulo underscore division, right? We define a string named temporary divisor, and we'll assign the divisor to it, alright? Then we'll again define a string named temporary dividend, which will be equal to dividend dot substring, and give the I hope you know what this substring function does. We pass it two arguments. The first argument and the first and the second argument are respectively the start and end point of the substring we hope to consider, right? So what we are doing here is, even though we are having 1 2 3 4 5 6 and 7 bit number, for XOR we consider number of dividend equal to the number of divisor. That is we XOR a 4-digit number with 4-digit number only, a 3-digit number with a 3-digit number only, right? So for that purpose we do this, and obviously as it's temporary we are going to update it. So we are going to divide our dividend by the divisor in groups of 4. So first we will divide our dividend from 0 to 3, then 1 to 4, then 2 to 5, 3 to 6, and we'll stop there. We will not do the final XOR into the while loop, and I'll tell you why. So okay, so first we need to define j, right? So int j is another length variable which will have the length of generator, right? So while j is less than the length of dividend, so for the starting case this will be, let's 4 less than 7, right? And we will do temporary dividend is equal to function of XOR, which we will write. So let me just type it here. Temporary dividend will be its first argument and temporary divisor will be its second argument. So function XOR is going to return me my temporary dividend to further my loop. Okay, we will see what this actually does when we go into the XOR loop, XOR function. Then we write temp dividend is equal to temp dividend plus dividend of j. Now we know that while doing XOR, the first bits of both the divisor and the dividend are always going to be 1. If not, we are going to take care of that into the function. And XOR of 1 1 will always give us 0. So we are going to drop the 0th bit from there. So if we are dividing the from 0 to 4, 0 to 3, we are going, after doing XOR, the 0th bit will definitely be 0. So we are going to drop it, and then we are going to shift 1 forward and divide from 1 to 4, right? So this j right here, dividend of j, is what is going to add the 4th bit to your dividend. And there will be one final result here, which will be equal to, let me just type here and then I will tell you what we are doing. Function of XOR temp underscore dividend comma temp underscore divisor, right? And don't forget the semicolon. So we are going to leave our final iteration of XOR over here, because the last XOR will actually give us the checksum, right? And that checksum has to be added into the result, right? Like we got in the example we solved, we got 101 in the end. So we are going to add that checksum into our input. Hence the concatenating sign here. Okay. Now to understand it a little better, we are going to write the XOR function. So string function XOR having string A, string B. We are going to catch the variables in this manner. Then we add a string result and instantiate it, initialize it. Then we are going to check if the zeroth element that is 0 or not, because if it's 0, we will have to return a dot substring starting from a dot substring starting from 1. Okay, now when we write a dot substring of 1, it means a of a dot substring, the substring except 0, that is from 1 to the length of the string. So we just drop the 0th one here and return to our modulo division function here, right? So as I told you, if it's 0, we drop it. So like if our is like this 0 1 1 0 1 or 0 1 1 0, right? So this function is going to return back 1 1 0, and the modulo function will further add the next element. If the next element is 1, this will become 1 1 0 1, and then we can do a proper XOR on this, right? So this is the case if there is 0 into our string A. Then else we are going to write a for loop, because now we have to do XOR for int I equal to 0, I less than length of generator I plus plus, and we are going to assign result we are going to append or concatenate result with, let's use a ternary function operator here. A of I is equal to, if A of I is equal to B of I, then return 0. That is, if it's similar, XOR returns 0. You must have gone through the truth table. And if it's not similar, if it's 0 1 or 1 0, then we append 1. So that way we get the XOR result completely into our result variable. Okay, and then we return result dot substring of 1. Now you may know that every single time, if the first bit is not 0, right, we have taken care of that already. During XOR, always the first element is going to be 0 for the result, because the divisor and dividend will both have ones at the start, and 1 1 will give us 0. So we have to drop that 0 and continue with the further modulo division, that is further XORing. So this will return the result back to modulo division right here, and our temporary dividend will get updated in the similar manner as before. Okay, then we will add the next element into the group. So if our return result is 110, we will add the next pending jth element as 1 and then continue the loop. Okay, so this way our XOR will be completed and we will have a final result, that is the final checksum in here. Now this statement right here comes into play, the one which we didn't consider into the while loop, because the final iteration will give us the checksum and we will add it in our input here. So as I said, if our input is 1101 and our checksum is calculated as 101, so we will just this statement right here will add 101 to the end, right, and thus we will get our final result. So till now we have written three functions: the crc.getData, then the getData called modulo, and then modulo called XOR. So we have written three functions here. Now we will write the sender side code, which is pretty easy. The void sender side doesn't return anything. It just shows us that what the input was, what the divisor was, what the dividend was, and this was the result. Okay. Now comes the turn of receiver side, right? Because it's going to receive, and this is the code for receiver side. It is very easy, and we are doing nothing new here. We are just asking the user that what was the data you received, right? So we will enter the data received. Then we are going to do the same procedure of division. Okay, and what we are checking here is if there is in the division which we did, if the remainder is 0 or not. If the remainder is 0, then we have no error, because after adding the checksum, when we actually divide it again, then there is no error. But if we slightly change a bit here or there, the remainder will not be a the remainder will be a non-zero, so that will indicate a 0. So that is what we are doing right here. We use the same file. We just change the name a little bit. Then we use a flag which we check if the error is 0, if our result is non-zero or not, and if our flag is 0, that indicates that the remainder is 0. We say out that yeah, the data is correct and without any error. Else we see out that data is received but with some error. Now we will try to compile and see if it works or not. So as I'm on Windows, I'm using the dev C++ IDE to compile my compile and run my C++ code. You may use whatever you want. So let's compile and run and see what. Okay, first we have to save it. Let's give it crc.cbp. Save. So it says that we have an error right here. If a of 0 is equal to 0, so we don't use double quotes here, we use single quotes. Okay, then we have another error here. We messed up the spelling of while, so we correct it. Then we again compile and check. Please do the similar corrections there, and so it's ready and without any error, and we are giving the input as the example which we took, 1100. Then it's asking for the coefficients of the polynomial, which we will enter as 1101. Okay, so as you can see, it shows input, the polynomial, dividend, and the data to send with our checksum, which is equal to 101, which is exactly same as the example which we solved on the paper. Then now here we can have two cases. Enter the data received. We can say that we received the same data, okay, and the remainder is 0. So it says, yeah, okay, so correct data is received without any error. Now let's try the second case where we will receive data with some error. Okay, so we will change the, let's say, the second bit here. So we will do 1 0. We change the second bit, which was 1 to 0, and keep the rest as same. So it will give that remainder is non-zero, 0 1 1, and the data received contains some error, right? So this is how CRC works. So this is it, guys. That's it for today. We have successfully understood what is CRC and implemented its code in C++. So this will come pretty handy in your practicals. You will definitely get passing marks, and if you uh, implement it as it is, you can even score out of marks. So please like, share and subscribe to our channel, and comment if you have any doubts in the comments below. We will be sure to sort them all out. Thank you and have a nice day.